Hi, welcome to this lab class. Today we are looking at wire bonding. Now before we go to wire bonding, let us understand and recall why we need to learn this particular process, right, and what exactly wire bonding is. So if you see the screen, what we have been looking at is the silicon ball, right. You remember we have seen Czochralski technique, which is CZ technique, we have seen float zone technique, and then we also know that 95% of the silicon or the semiconductor devices still today are made up of silicon, which is a substrate. Now once you have a bowl, the purity of this particular silicon needs to be 99.9 times 9, and we also know that this kind of bowl can be fabricated or can be developed, right, or we can make this kind of bowl in a fab lab, or we can say foundry. So from how the silicon bowl is made and what we do with the silicon bowl, we know. From silicon bowl we can get the silicon wafers, single side polished wafer, double side polished wafer, that also we have seen. And then once we perform this slicing of this particular bowl and then polishing, CMP, which is chemical and mechanical polishing, grinding, right, and then we can get the silicon wafer of different size, that means a 4-inch diameter to 12-inch diameter and of bigger diameter as well. What we do the entire process flow to fabricate our devices. Now once you have the devices, what you do with this entire silicon wafer, because in one silicon wafer you have many devices. So once you have many devices, you slice this device or you dice this device, okay. So dicing is a process by which you can have individual die. You can see in this particular screen this particular image where you have silicon wafer, and each of this particular rectangle that I am drawing here is a die, alright. So you need to dice this, each of this one, and then you can place it in a packaging system where you can do the wire bonding. So with you see here there is a silicon die, right, with lot of circuits integrated onto it. Now it may be ASIC, it may be something else, right. When you say ASIC, is application specific integrated circuit. Now once we need to take the contact from this particular die to the external pins, which we generally call as a integrated circuit or IC, and these are our pins, right, of the IC. The internally when you open this casing, what you will find is a chip. This is a silicon chip, and this silicon chip there is a wire bonding. So from the chip there is a wire that comes to the bond, alright. From chip there is a wire that comes to the bond here, like this, 1, 2, 3, 4 and so on, alright. So this process of how the wire bonding works we will be recording, we have recorded it in the lab class. So you will see how to utilize this tool, very important tool. Now we have taken example of a chip, but in this course what we are looking as a device, right. Either it is a PMUTs or piezoelectric micro machine ultrasound transducer arrays, or it can be any sensor. It can be gas sensor, it can be pressure sensor, it can be temperature sensor, it can be accelerometer, right, it can be any sensor. If you want to take the bonds, if you want to take the contacts from the sensor all the way to external electronic module, right, and that particular sensor is made up of silicon and the pads are made up of gold or platinum, right, you can use wire bonding. There are different kind of wire bonding, but we will not go into detail of those particular aspects, but I hope that you like this lab class and you learn something out of this lab. Till then, have a nice time with the lab class. Thank you.
Hello everyone, in this lecture we will have a demo on wire bonding machine. My name is Srinivas Bhaskara, one of the TAs of this course. So what exactly a wire bonding machine does, right? I'll make it very simple for you, right? You might have seen a soldering, right? People take a lead, right, and they melt it, put it at the contact where they want to connect it, and that's how the soldering will take place. So there the method and all a little bit different compared to this, but more or less the concept is the same. Here we are again doing the same kind of contacts, taking from those pads at a micron level. Okay, the pad sizes are very small here. let's say when I say small, it can be 300 micron by 500 micron pad, right? Where the traditional soldering may not work, right? Now, what I also have a lot of devices to show you how difficult it is to try it out using a soldering gun, correct? Because soldering gun has to be precisely small. Okay, so if you want to do kind of like do soldering at micron level, okay, what are the alternatives that we have? One of the alternatives is the wire bonding machine, and it's kind of the technology that uses is a bit different, right? So there are one way of doing is ultrasonic power, like you use the vibration as energy to melt the material and apply some force, and then make sure that the metal and the wire are in contact, correct? And take that wire on somewhere else, and then again do the same procedure. Or you use thermal energy, okay? You heat it up, you make sure that metal gets melted, and then try to apply that. I mean, it's not like just a thermal energy. You also use ultrasonic power and pressure also at the same time, right? So here what we use, we have ultrasonic power, you use a force, and with a particular contact time, right? Based on these three parameters, the machine will work, right? So if it is aluminum, you can use ultrasonic power. If it is a gold, then you have to use thermosonic. Along with vibration, you also has to supply some heat so that the gold will bond to that particular contact pad, right? So in the next few seconds, I'll show you some of the devices where you can feel that, right, what is the importance of wire bonder, right? So let's have a close look at those devices now. So let's look at these devices, okay? Now these are all the neural implants that we use for rodent models. Forgetting about those application point of view, if you look at this implant has around 11 to 12 electrodes, if I remember correctly, right? Within that, along the shank, and there are the contact pads here for individual electrodes, right? So you look at this one, this has 4 shanks, this has 3 shanks, this has 1 shank, and finally if you look at it, right? So if you can zoom in a bit here, right? There is a neural implant and there is an electrode interface. The green color board that you can see, right? This is called as electrode interface board. Now in the fabrication, we will fabricate this guy, neural implant, separately. Finally, it has to be interfaced with electronic systems, right? How do you do that? Now you put it on the electrode interface board, that is that green color in here. Now you die attach it, okay? You put some epoxy and then fix it. Now how to get the electrical contacts, right? You look at the pads, right? So I think we will change the view right now and then show from the top view how does that look like, and then see how wire bonding takes place subsequently. Now if you zoom in and then see here, this is the structure, right? Now the green part is electrode interface board. This is FPC connector. The other end will be connected to the electronic systems. It can be stimulation system, recording system, whatever. And if you see this one, right, you can see so many electrodes are there in that. If you only have microscope, if you see, then only you will understand. Otherwise, you will not understand. But take me for granted that there are around 13 electrodes in this. Now you can see the thin wires that are coming from the implant to the board, electrode interface board. Now you can see, if you can see that dimensions, right, it is around 30 micron thin wire. And you look at the contact pads. Contact pads are very, very small. And now can do you think that soldering is possible literally from there to the contact pad? Also you see the contact pad here on the electrode interface board. This is also very small. Contact pad on the neural implant is also very, very small, right? Now how to get the electrical contact from the neural implant to the electrode interface board? Now that is where we give much benefit, or we can say that much credit to the wire bonder. Okay, so when the contact pads are very small, right, that's where the wire bonder will help you, right? And this is what precisely IC industry also looks at it, right? Because as the dimensions of the transistors are reducing, right, the contact pad size is also reducing. So the way you get the electrical connections between the pads also need to be in the same order, right? So that is the significance of a wire bonder. Now we will look into the system peripherals and then see what are the different things present in the wire bonder. Now let's look at different peripherals of wire bonder. Okay, let's see what are the things that we have here. Now so this is the tool. Okay, let me show you where it is. You see the tool. This tool, if you look at the diameter here, right, that's from there that wire comes up, and then we will do the process, and I will show you how exactly it works. And that diameter of that particular wire that comes out is around 30 micron, and that tool dimension, if you look at it, is that end dimension opening is around 80 micron. So it's very precise, and it is made of tungsten so that it can withstand very high temperatures. Okay, because tungsten, we all know that it has very high melting point, right? Now I have a zig here. Okay, so it's like a gearbox. Okay, so yeah, I can move the stage. You see the movement of the stage if I'm doing like this, right? It is trying to push right, left, right, something like that, right? This is very important because when you are doing a bonds, right, you may need to move from one place to another place. So this will help you to move the stage. Now this is the holder, substrate holder, if you look at it. Now it also, you can see the symbol here, right? What does it mean? Something like hot. That means that this stage you can heat it up whenever you are doing gold bonding and all those things. Alright? Now one more tool I can show you. I can just open in front of you guys and then show you how it looks like. And mind you, these tools are very costly, right? Can you see this tool? You see how thin it is. Right? So depending on the material that you are using, we have to change the tool, and depending on the type of bonding that we use. Okay, we have ball bonding, we have wedge bonding, we have ball bump, different configurations. All right, now what are those different things? I can briefly explain you once I show you all that, the GUI and other stuff. Now I want to show you the spool also. Can you see this one? Right, this is spool, and if you look at the thickness of, this is a gold wire, by the way. I think it is around 25 meter long, and the diameter is around 30 micron. Inside, there is an indication for the end and where you have to start. This is the indication for the start, the green color spot. Right from there, you take out the wire and then start fixing it. And if you look at this machine, right, that spool is present inside this box. Right, and you can also see a closer look of that in a few moments. Right, so let's have a closer look at it. Yeah. So as you can see, right, there is a very thin wire, very difficult to identify because it's 30 micron, less than the diameter of a human hair. Now it is coming out from this port, and that port is connected to the spool, and that wire will directly ends up going to the tool that I have shown you, capillary that I have shown you, right? It goes inside that, right? And that's where the mechanism takes place. Yeah, so we have seen the jig controller, and there is a stage, correct? On the top of the stage, the one more stage will come, right, where we can fix the PCB and all, right? So as you can see, right, a PCB has been already fixed, right? And if I move this, the entire setup will move, right? And it is also connected to the heater, right? I can set the temperature so that the PCB gets heated up during gold bonding. Also, if you look at this one, right? So one can manually do the bonding. Now it's automatic bonding. Now one can manually do it, and we I can say that we don't use it or we rarely use it anytime. So let me turn on the machine and then see what will happen. Okay, just I will move this stage a bit far. Okay, this is called holder stage, okay? The stage that is holding the holder. Now this is a company from a company called TPT. So whenever the thing turns on, right, as you might have seen that there is a the height of this has been changed, okay? The capillary has moved down, correct? So make sure that there are nothing nearby that. Otherwise you end up breaking the capillary and it's very costly. We have to import it, right? Now, what are the different options available for us in this machine particularly? I'll explain you by exploring the GUI. Let's focus on the GUI. Yeah. So now, if you look at it, there is an option for height setup. What does it mean is, right? So if I take a same example here, right? Now you see, you have to get one bond in the neural implant and you have to bond it to the electrode interface board, and you see there is a clear-cut difference in the heights. So those two bonds are at different levels, height levels, correct? So the machine will calibrate what is the height bond 1 will takes place and what is the height bond 2 will takes place. So that is the reason why we need a height setup. Now there is something called, I'll explain everything experimentally, don't worry, these are different options available. This is test USG, okay? So when there is a dust or something like that, something is blocking the end of the tool, right? So if I click on the test USG, it will give some kind of ultrasonication such that the particles will be out. Now there is some option, there is one more option called loop height, right? Now if I can program this, right, I can make it whatever it is. So what is that loop height is when you make a bond. So bond 1, you contact, you create a you will what I can say is you form a contact at bond 1 in one area and you will go to another area for again forming a contact, correct? So how much should be the height, vertical height is the loop height. Now why way? Now what is the horizontal distance between the bond 1 and bond 2? Right? You might be a little familiar, or after some experience with this you will understand how much you may need, whether they are very close, very far, somewhere in the middle or something like that. That also you can program. Let's say it's very far, then you can choose whatever the number you want to choose, right? Now bond 1, you can see the US, right? So it's ultrasonic power, how much we have to give. So here it is, we are giving 220 milliwatts. If you look at this one, right, you are giving 220 milliwatts. Now what is the time it has to contact? Like let's say the tool will come and then form a contact with the contact pad, right? Now how much time it has to stay there, right? So the tool will come and stay there and then move out. Tool will come, stay there and then move out, okay? So the time is 200 millisecond, and pressure, like force, how much is the force that you are applying? 250 millinewton, right? So what happens is you melted the material and you press that material against see the tool has, okay, can we zoom on the tool here? So the tool, from the tool, maybe once I do the bonding you will understand clearly. From the tool the wire will come out from the end, okay? Let's say this is the tool, the wire will come out from the end, right? Now because of the ultrasonic power this gets melted, the end of the whatever is at the end, right, that metal gets melted, either aluminum or gold. Today we will see aluminum, that will be melted. Now you go to the contact area and touch it and apply some force and then leave it. That's where the bonding happens, correct? That is the principle of ultrasonic power along with the force, right? So again, similar concept you can use for bond 2. Now there is an option here, right? There is clamp close and clamp open. Now this is very, very important because, right? Now again, if you focus on the tool somewhere here, right? I think you guys are able to see, right? Now this is called a clamp, right? This will hold the wire so that it can move the wire up and down, right? So there is a time that you have to move the wire up if there is an extra wire coming in out, and there is a time that you have to move the wire down, right? Through this everything will happen, right? So one should be very, very careful with the clamp, right? Also you might have seen the lights here, that setup that we have, right? And let's focus on the GUI again. And there is something called program number, right? Program wedge. And you can see there is something called wedge bonding, right? Now, whenever you bond with a surface, right? At the surface, if you leave a ball kind of mechanism, right, that is called ball bonding, right? So, if you take a surface like this, you create a ball like this, and then wire will come out from here, right? So that is called ball bonding. Otherwise, it is called wedge bonding, right? And here we have an option for ball bonding. We have something called wedge bonding. Then there is something called ball bump. Again, back to the wedge bonding, right? So these are the 3 different options that we have, right? So generally, if you want to maintain a lot of strength with the surface, better to have a ball, okay, something like this, so that the strength of this bond is very high compared to the normal wedge bonding, something like this, right? Now let's look at another option. There is something called semi-automatic, manual, right? So in the manual, what happens is, if you are in manual mode, you have to go with the tool towards that contact pad area, step by step, using this lever I showed you earlier, right? And we don't use that anymore at all, but for some applications we may use. Then there is something called stepwise, it will move in stepwise. Then there is something called fully automatic. So once you give the location to that, then bond 1, bond 2, everything will taken place on its own. So here you have to mention just that loop height and Y wave. That's all. You don't have to do anything. Then semi-automatic, what you should do is, in semi-automatic, how it is different. So it will do bond 1, first bond, and go and stop near the bond 2. It will not bond it, it will just stop. In fully automatic, what happened? Bond 1, bond 2, both will happen. It will go to the bond 1, bond it, location of the bond 1, it will go to the location of the bond 2 and then bond it and then come out and then it will stop, right? And depending on number of bonds that you have given, so many bonds will be done in a given time. That is fully automatic. In semi-automatic, bond 1, we have to literally take it to the location, then you have to click on that, then bond 1 will take place, then it will go to the bond 2 and then stop. Again you have to click on that. Okay, it's somewhat semi-automatic. Now semi-automatic. Now what is manual? Everything you have to do it, right? You have to manually take it there, come down manually, right? It will not go automatic, right? Then bond, then go to the bond 2. Everything has to be done by you, right? So this is useful when there are very specific applications, right? Now what I will do is, let me click on the height setup. What is it saying right now? Can you guys read it? If you can zoom, it is showing move to first bond and press bond button. Now in the controller that I have shown you, right, if you can see, there is something called bond button, then there is something called up button, then down button, then reset button, right? Now if you want to do any bonding, you have to click on the bond, right? What happens is, the tool will go there and stay very close to the contact pad. it will not bond. It will just take very close. Once you release the bond, then it will bond and then come out and then go to the next place, right? First place, like once you click on the bond, what happens? It will go there, stay there. Release the bond button, it will bond and then come and go to the bond 2 and then just stay there. It will not bond, right? Because it's a semi-automatic. Correct? Again, if you click on the bond, it will press and then come out. Right? So I'll tell you the methodology, right? So that's a bond button. Then up and down. So down button, if you want the more wire to come down, you can click on the down button. If you want the wire, if there is a lot of wire hanging, so you want to move it up, you can click on the up. Now let's say you want to reset it. Let's say first bond has not happened properly. You have to reset entire thing. Just click on the reset. It will come back to the home positions, wherever you started. Right. So this is the controller part. Now let me take this, the substrate or PCB holder. Now you see, one has to carefully handle it when dealing with this. Just for our understanding, what I will do is I will fix one place. Now you have a microscope, right? I can adjust the microscope. Let's say this is the place where I want to do bonding, right? So what I will do, according to the GUI, what is the instruction? Move to first bond and press bond button, right? Let's say this is a location somewhat near, right, where I have to do bonding. So I'll just click on the, okay, let me adjust it nicely. Right? I hope you guys can still able to see the bond button, right? So I'll just click on the bond button. Let's see what happens. See, you can see the tool coming down. You can see here, right? The tool is coming down and touching the surface. Right? Now it is asking, what is it asking now? Move to second bond and press bond button. Okay, let's say, okay, I'm moving the stage a bit, right? And again, press on the bond button. And you can again see the tool coming down, right? The capillary is coming down. You see, it is touching. And finally, the message has come like setup OK. Means it has calibrated what is the height of the, or I cannot say calibrated, it has measured where is the height of the bond 1 and where is the height of the bond 2. Where can we see that? Just go to advanced settings. You can see this one, right? SH bond 1, SH bond 2, right? So 3485, 3486 means if you look at that PCB, right? If you look at this PCB, it's a planar PCB. You see that? But for some other PCBs, it might be different, like the way I have shown you earlier. That's why it is precisely saying that both are at almost at the same height, exactly at the same height, like 1 micron distance. Okay, that much variation is acceptable. That's fine, right? Now this is the working height, right? So from the home position, where exactly the tool is right now is around 5486, and you cannot go beyond certain height. Otherwise, the tool will hit the bottom and then break. Correct? So that's one thing. Then this is tail step, right? So what is this tail step means? Suppose if I press on the bond down button, how much tail should come down? Now according to this, 80 microns should come down. Now if I press on the down button, 80 micron come down. If I press on up button, 80 micron will come up, right? So for the adjustment of the wire height. Then tail feed, right? So once the bond is formed, correct? It will go to the next stage, next bond, bond 2, right? Bond 1 is done, bond 2 it will go. How much it has to release for the bonding to take place? Around 200. So this is optimum parameters that we have sent. This is more or less how the GI look like. Now once if you are okay with all these things, go to the bond, okay, you can start bonding, right? Now what I will do, from outside you can see how I am doing. Then we can focus on the eyepiece and then show it to you, because we cannot directly record everything. So let's look at from the outside how it looks like. Then we will go into the eyepiece and then see how exactly the bonding is taking place. Okay guys, so let's see how it looks like from outside, right? I'm just repeating again. So by now you should be very clear. This is a controller which controls the stage and bonding. Then this is the setup that can move. You can move the stage, right? Also one might be thinking, right, how to fix it, right? You can see this one, right? Now you have a clamps here. I can move this, take it out, and you can fix whichever the stage or whichever the PCB that you want, right? So let me fix it back to you, right? And also you can release these two, right? I'll show you, right? You can use this Allen key, right, and release these two screws and then remove that, right? So that the size may not be a big issue, how the size of the PCB should be, right? Let me put it back, right, and go back to the place that I'm intending for. And as you can see now here, right, so you have a lens, right? So through this you can see, right, because there's a very the size is an order of microns, correct? So right, so I just clicked on the reset, so it has come back to the original place. So while I'm taking out the stage, I clicked on the height setup so that it will go a little far and then stay at the home position. Okay, I'll show you again, because I want to move this stage outside, okay, and I should be very careful. I should not touch the tool. If I damage the tool, it's very costly, I told you already, right? Now because I didn't do anything right now, I just want a demo purpose, I just click on the reset. You see, exactly it came and stopped there. Now what happened? I carefully look into this. Now to show you how the things are happening, now ideally I should use left hand for this, for bond and all, but in the video I think if I put a left hand it is going to block the view for you. So what I'll do, I use a right hand, but understand that we should use a left hand for that. But you can see, can you focus on this? So this is a bond button, correct? Now if I click on the bond button, and I want you to focus on the this controller and the capillary. Now once I click on the bond, there will be some sound that comes, and then the tool will goes down and stay there. It will not bond. Only when I release, then the bonding will happen and the tool will go to the next position, right? So let me show you one by one. So let's say I am clicking on the bond, right? If I click on the bond, you see that it went there and then touched. Now you see, right? Okay, I'll do one more time, no problem. We can do one more time. Wait. I'll just let me complete this bond. Right? So let's focus on that. Let's get this. This is called, what is this? Trial 2. Now let me click. So just focus carefully. If I click on the bond, you see, the tool has come down. Now I didn't release the bond button. You can focus on the bond right now. I am just still pressing it. Now if I release this, you can hear the tick sound. That means the bond has taken place. And now if you look at it again there, right, it will not be touching the surface. It will be still at the very close by. Right, now I'll just finish this. Then I'll show you through the eyepiece. Through the lens we'll show you how it will be. It will be very good to see. Right. So again I release the bond button and bonds have taken place. Right. So now this is outside view, how it looks like. Let's look through the lens and later on we'll conclude the session. Now you look at it. This is a wonderful view, right? Now you see already we have formed 3 bonds, right? Now you go to the desired area. Let's say I want to bond here, right? Let's go. I am just clicking on the bond. You see, it didn't bond, it stayed there. Okay, now I'm releasing the bond button, right? It didn't bond properly, right? So what I'll do, I'll click on the reset. It will come back to the position. Now I'll do a little bit, I'll do one thing, I'll show you, just for the demo purpose I did this. I'm just clicking on the down button. You see that? You see the tile that is coming there? You see, little bit down. I'm clicking on down, down, like that. If I click on the up, you see the wire is going up, right? So now let us try the bond. Now, okay, let me try the bond here. You see the bonding taken place, right? So now again I will press on the bond. You see that it is not bonding now, it is just staying there. I can move anywhere, wherever I want, like this, like that and all, okay? If I release the bond button, bonding will take place, that's it. Now, something like that, we'll try one more bond here, right? Assuming that this is the bond 1 area, that is the bond 2 area, right? So you do the bond here, that's it. Okay, now what I will do, I will change the Y way. Now instead of 1000, it was earlier, I will give it 500. Now let us see how the bonding will be. Now Y way, what it will change? Think about it. I told you already. If you have not watched the video, you watch it completely. Now you see this? Can you guess the difference? The difference is the Y length. You see this one? This bond is little bit lengthy compared to this bond, okay? So we'll try one more. Right? You go closer, you try one more. Right? So that's all about this bonding that takes place in a micro view, right? So let's conclude this now. So we have seen how a wire bonding machine looks like from outside and from inside views, GUIs and different parameters like ultrasonic power, time, force, okay, these different things. And we also seen one demo, right, on how a wire bonding looks like, right? Not one, I think multiple we have tried with changing in the loop height, not loop height, Y way and all those things. But what exactly would be the application from industrial point of view? This is what I have shown is for just a lab demo purpose and neural implants and all. Now let's say for example you have a chip that has some 10,000 contacts that has to be brought to the interface board. Like you might have seen a lot of chips, right, in your mobile phones and all. Every chip might have some 5,000 contacts, 1,000 contacts, 500 contacts. And that has to be precisely connected to the electrode interface board or a PCB for the applications. So one can use an automatic wire bonder where you have to just take the image, mark where is bond 1 and bond 2. Through algorithms, it will understand what should be the height of the bond 1, what is the height of the bond 2, what should be the height, loop height, what should be the Y way. It will only analyze the optimum parameters and it will start bonding. So the machine can do almost like 60 to 120 bonds per minute. Okay, that's what is required in industry, right? Less interference from the men or the workforce. Understand? So that is fully automatic wire bonder. In semi-automatic we have seen already. Okay, it will go there, stand there, bond. If you release the bond button, press and go to the next location depending on Y way, depending on the loop height. Again you press the bond button, it will go there and stay there. If you release the bond button, then only bonding will take place and then go there. Correct? Manually, right, you have to do everything, like you have to go there, stand there with the tool, press on the bond, then bonding will take place. then again it will stay there, then again you have to pull it up, go to next place, again put it there. It's a pure manual mode. All right, that may be useful for a specific application, right? But it may not be effective. You can think about it, how many bonds you can do in a minute, correct? So that's all about our wire bonder. I hope you enjoyed this session. See you soon with other content. Thank you.